So this video today is our calculus video on lesson 6, which is the mean value theorem. So let's go ahead and jump right in here. So the mean value theorem says if a function f is continuous, well, that means that that it looks like this, okay? That there's no holes in it, there's no jumps in it. It's just a continuous function over an interval. And we're going to talk about the interval a, b here. And those brackets mean it's a closed interval. So we're going to talk about like a point A here and a point, we'll say B over here, okay? So that's the interval that we're talking about. It says, and it's differentiable. That means you can take the derivative of it over the interval A, B. Now this means, so remember that bracket means you include the values of A and B, whereas the parentheses mean you do not. Then there exists a point C within that open interval where the instantaneous rate of change, so this is a point C here. Instantaneous rate of change is the derivative, okay? That's the derivative of the function. And it is the tangent line, if you remember. Okay? Then it equals, that's the key word there, equals, okay, it equals the average rate of change. Well, average rate of change is just, that is going to be our secant, and I'm going to show you that in a second. But that is the change in y over the change in x, right? That's like y2 minus y1 over x2 minus x1, okay? So when we're talking about the secant, that's where it intersects the graph at 2 points. So we're just going to make this our b right here, okay? And that's going to be our a value, right? So that's the secant, right? So, and to find the slope of that line, we just, again, take the points and we subtract them from each other. But then when we talk about the instantaneous rate of change, that has to do with where this line is going to be parallel and tangent, right? Tangent to there, that's the same line, right? Essentially. And then, let's see if I can find the point down here like this. Tangent to the curve right there. All three of those lines are parallel, right? And these would be our point C's. That would be a point C right there, and this would be a point C right here. Both of these would be our C's, okay? Because that's where the slope is equal and tangent to the line, okay? So when we're talking about average rate of change, we are talking about our A's and B's, right? So we're going to do and remember this point right here would be f of A, and this point up here would be f of B. So remember, we're going to do our f of B, that's our y2 minus our y1 f of A, right? And we're going to, that's going to be our change in y over our change in x, right? So this is just going to be b minus a, okay? So that's going to give us the slope of that black line. Then the instantaneous rate of change is just a derivative of that. That's really what it is, okay? So that means we're talking about our blue lines, and that would be the derivative of our function. And I'm going to say f prime of x, but here's the deal. Often they say f prime of c, okay, when they're expressing it. So now what are we doing with these two things? We're going to set them equal to each other, okay? So we're going to take our f of b minus our f of a, and our b minus a, and we're going to set that equal to our point down here, our derivative. And I'm just going to put, because for me it makes more sense if I just say f prime of x, because we're just going to take the derivative of the function. Okay, we're going to set these two, the slope equal to the derivative. This is going to be the slope of the function is going to be equal to the derivative, or IVAT, of the function, okay? So this right here is the mean value theorem, okay? That's exactly what it is. Take the slope of the function and set it equal to the derivative of the function. Solve for x, okay? All right, that's what we're about to do down here. So we're going to solve for, we're going to plug the 2 in for the x, and we're going to plug the 6 in for the x. So we're going to say f of 2 is going to be equal to negative 2 squared plus 3 times 2 plus 10. Put that in your calculator, and you get 12. Okay, then we're going to do f of 6, and that's going to be negative 6 squared plus 3 times 6 plus our 10, and that one's going to be negative 8. So again, remember we're doing delta y, changing y over changing x, right? So that's going to be 12 minus the minus 8, that would be plus 8, right? And then 2 minus 6. So that's going to be 20 over negative 4. So that means this value is going to be negative 5, okay? Now, the next part says on the interval, when does the instantaneous rate of change equal the average rate of change? So see it says equal here, but we need the instantaneous rate of change. That's going to be the derivative of this function. So I'm going to do f prime of x, that's what we're about to find. So the derivative of negative x squared is negative 2x. The derivative of 3x is 3, right? Now what it says is we're going to set that equal, right, to this guy right here. So we're going to do negative 2x plus 3. And it's going to be equal to our negative 5. So what do we do to solve this? We're going to subtract 3 from both sides, right? So that's going to be negative 2x equals negative 8. We're going to divide both sides by negative 2. So the answer here as to when they are equal is x is equal to 4, right? And that is because... And I want you to notice that 4 is between 2 and 6, and this answer has to be in that interval, okay? Really important. That's how you can double check it. All right, so we're going to use the mean value theorem again, okay? So for our next example, so once again, we're going to just put in our negative 4 and our negative 2. So we're going to do f of negative 4 equals, and we're going to do f of negative 2 equals, and so this would be negative, or this would be, sorry, negative 4 squared minus 5 times negative 4 plus 1. And when I did that, I got 37. Then we're going to do negative 2 squared minus 5 times negative 2 plus 1. And on this one, I got 15. So again, we're doing delta y over delta x. So that's going to be our y values, 37 minus 15 over negative 4. Minus 2 would be plus 2. So that's going to give us 22 over negative 2, which would make this negative 11. Okay, now we're going to take the derivative of the function. So we're going to take the derivative of this function, the derivative, so f prime of x is going to be 2x, and that's going to be equal to minus 5. Now we're going to set that equal to our negative 11, right? So what do we do next? We add 5 to both sides. So this is going to be 2x equals negative 6, and divide both sides by 2. So x here is going to be equal to negative 3. All right, now the next one's a little tricky. Obviously, the first part's not, but the second part will be a little more tricky, okay? So here again, f of 1 is going to be equal to the square root of 5 times 1 minus 1, which would be 5 minus 1, which is equal to the square root of 4, which this would be equal to 2. And then f of 10 is going to be equal to the square root of 5 times 10, that's 50, minus 1, that's going to be the square root of 49. So this one's going to be equal to 7, okay? So here again, remember we're doing delta y over delta x. So we're going to do 2 minus 7 over 1 minus 10. So that's going to be equal to negative 5 over negative 9, which would be 5/9, okay? Now, this is the part where people might mess up. So remember, this function is 5x minus 1 to the 1/2 degree, right? So we're going to take the derivative of this. So f prime of x is going to be equal to, we're going to bring this out front, remember, subtract 2 over 2 from it. So this is going to be 1 over 2 square root of 5x minus 1. Because remember, that's going to end up being a negative 1/2, so it's going to the denominator. Okay, so now that's going to be equal to our 5/9. Okay? Whoa, wait. I made a mistake. We still have to take the derivative of that, right? So that's going to be times 5. So when we do this, this is going to end up being 5 over 2 square root of 5x minus 1. Because remember, we have to do the derivative of the inside function too. That's going to be equal to 5/9. Now, hopefully y'all remember from your algebra days that these two can cancel each other out, and we can just set that equal to each other, right? So now I'm going to divide both sides here by 2. Okay, so that's going to give me the square root of 5x minus 1 is equal to 9 over 2. How do we get rid of a square root? We have to square it on both sides, right? So we're going to square both of these. So that's going to give us over here 5x minus 1, and that's going to be equal to 81 over 4. Then we're going to add 1 to both sides. And obviously to add 1, we're going to do our 4 over 4, right? That's what's going to get rid of our 1. So that's going to be 5x is equal to 85 over 4. Okay, now we're going to divide both sides by 5. So what does that mean? We're going to divide the 85 by 5, right? Okay, so that's going to give me 17 over 4. Well, 17 divided by 4 is 4.25. That's my x value, okay? So is 4.25 between 1 and 10? Of course it is. So that is a valid answer, okay? All right, let's see if you guys can do these next two and come back to me when you're done. No, actually, we're going to do these two. My bad. All right, so here again, f of 0, that's going to be 9 is 0 squared minus 4 times 0 minus 3, so obviously that's negative 3. F of 4 is going to be equal to negative 4 squared, that's going to be 16, plus negative 16 plus 4 times 4 is 16. That's going to be 0 minus 3, so that's also going to be negative 3. Again, delta y over delta x. So that's going to be our y changes negative 3 plus 3. And then we're going to do 0 minus 4. So that's going to be 0 divided by negative 4, which is just 0, right? So now let's take the derivative of our function right here. So this is going to be f prime of x. So that's going to be negative 2x plus 4. And we're going to set that equal to 0, right? So we're going to subtract 4 from both sides. That's going to be negative 2x equals negative 4. Divide both sides by our negative 2. And this one is going to be x equals 2. All right, so the next one is sine of, and this one's a little tricky, okay? So we're going to do the f of 0 and f of pi, okay? So that's going to be equal to the sine of 3 pi, and I put that in the calculator, or 3 times 0, sorry, 3 times 0, which would be the sine of 0, right? The sine of 0 is, guess what? It's 0. All right, and then when we do the sine of 3 times pi, that's also 0. So here again, when we do delta y over delta x, that's going to be equal to 0 minus 0 over 0 minus pi. So that's going to be 0 divided by negative pi again. So that's obviously going to be 0. So now, this is the tricky part. We're going to do the derivative of the function. And that's going to give us the derivative of sine is cosine. So the cosine of 3x. And then we're going to take the derivative of the 3. That's the chain rule, right? So this is going to be 3 cosine of 3x, right? Okay. So now we're going to set that equal to 0. So here's the question we have to ask ourselves. First, we're going to divide by 3, get rid of that 3 that's out front. So there's just going to be the cosine of 3x. When is it equal to 0? So when is cosine equal to 0? Cosine is equal to 0 at 3 different places, okay? It is equal at pi over 2. It is equal to 0. Cosine is equal to 0 at 3 pi over 2. And it is equal to it at 5 pi over 2. Well, here's the deal. We got to set all of these equal to 3x. And, you know, you guys should know when cosine is equal to 0. So then we're going to just divide by 3 here, aren't we? So that means both of those are 3, so that's going to be pi over 6, right? For our x value. Again, divide this by 3. That means the 3's are going to cancel out. So this x value is going to be pi over 2. And then divide this by 3 again. So this is going to be x is equal to 5 pi over 6. So those are our 3 values. And again, you have to know when the cosine is equal to 0 here. All right, so example 1. These are your tries. Pause the video here and see if you guys can do these. So f of 1 is equal to 2 times 1 squared minus 10 times 1 minus 5, and that's going to be negative 13. F of 3 is going to be 2 times 3 squared minus 10 times 3 minus 5. And that's going to be equal to negative 17. So again, we're going to do delta y over delta x. It's going to be negative 13 plus 17, because we're subtracting a negative. And it's going to be 1 minus 3. So that's going to end up being 4 over negative 2. And so this is going to be equal to negative 2. Okay, that's our slope. And then again, we're going to take the derivative of this function, f prime of x. So the derivative of 2x squared is 4x. The derivative of negative 10x is negative 10. We're going to set that equal to our negative 2. We're going to add 10 to both sides. So that's going to be 4x equals 8. And divide both sides by 4. So x is going to be equal to 2 here. All right, here again, this is one of those ones where you guys might struggle a little bit, but hopefully not. F of 4 is going to be 2 times 4, that's 8 plus 1, so that's going to be the square root of 9. That's going to be 3. F of 12 is going to be equal to 2 times 12, that's 24 plus 1. That's going to be the square root of 25. So that's going to be equal to 5, right? So again, we're doing delta y over delta x. So this is going to be 5 minus 3 is equal to 4 minus 12. 5 minus 3 is 2. This is going to be over negative 8. So that's going to be negative 1/4, right? Wait, is that right? Oh, I did it backwards right here. Should have been 3 minus 5. So that would have been negative 2 over negative 8. So this would have been 1/4. Okay, now again, we're going to find the derivative of this function. So remember, this function is 2x plus 1 to the 1/2 power. Multiply that out there, and we're going to have to take the derivative of the inside 2. So when we take the derivative of this function, it's going to be 2, because the derivative of the inside goes on top, and then it's going to be 1/2, right? So that goes on the bottom. And then we're going to take the square root of 2x plus 1. So notice what happens with these 2's. They cancel each other out, so that's going to be 1, right? Now we're going to set that equal to our 1/4 again. So notice again, these cancel out. So all we have to do is the square root of 2x plus 1 equals 4. This time we're going to square both sides. We're going to square this. We're going to square this. So that's going to give us 2x plus 1 equals 16. Subtract 1 from both sides. So that's 2x equals 15. Divide both sides by 2. So x here is going to be equal to 7.5, right? 7.5. And 7.5 is between 4 and 12, right? So that, again, that's our check. Like over here, remember this one over here was 2, and it's between 1 and 3, okay? So that's the way you check it quick, all right? So the next concept here is example 2a. A hot air balloon is launched into the air with a human pilot. The twice differential function. Okay, twice differential means two things. It means the function is continuous, and you can take the derivative of it, which is what it means by differentiable. So you have to be able to take the derivative of it. It has to be differentiable for what we're going to do first, or actually it has to be continuous for what we're going to do first, and twice differential means it is continuous. That just means that there's no breaks in the graph. And then the second part is, so I'm going to talk to you all about that in a minute. And then it says function h models the balloon's height measured in feet at time t measured in minutes. Okay, so we're going to talk about how we do this. So first of all, we're going to use the intermediate, it'd be great if I could write, right? Intermediate value theorem for this, okay? And from now on, we're going to abbreviate this, okay? We're going to abbreviate IVT, okay? So for this part of the question, when it's asking us, must there be a time t when the balloon is 50 feet in the air? So first of all, to be able to answer this question, the graph must be continuous. And we know it's continuous because it's twice differentiable, okay? So it is continuous. Then it's asking us for the values of t between 5 and 15. So between 5 and 15, those are our values right there, right? 5 and 15. I don't know why my thing is up, but it is between 5 and 15. Those are our values. And it says, will the balloon ever be at 50 feet? So obviously, when we're talking through this one, okay? So when at h of 5, the value for y is 40, or the feet is 40, right? And at h of 15, it's at 70. So here's the question. So isn't 50 between 40 and 70? It is, right? So according to, so what we're going to write for our answer here is according to IVT, there obviously this graph is going, if we're going from 5 to 15 here, right? And this is going from 40 to 70, it's going up, right? So we did the intermediate value theorem before now. So what does that mean? It means obviously there's a value between 5 and 15 minutes where the ball or the balloon is going to be at 50 feet, right? So that's what this means. So that if we write our answer, it's going to be 5 is less than equal to c is less than equal to 15, and what the value is, we're going to say 50 is between 40 and 80, right? 50 is between 40 and 70, sorry. Right? Isn't that logical? Okay, so now the next part says for 20 to for the interval between 20 and 30, there must be a time t when the balloon's velocity is 1.5 feet per minute. Velocity is what? Feet per minute, right? Y'all, isn't that what it is? It is. Okay. So that's what velocity is, feet per minute. So feet per minute. Okay. So what are we about to find? We're going to find, obviously, the slope, okay? Feet per minute. So what are we going to do? We're going to put these in for our x values, right? And we're going to look at our y values. We have our y values, right? So f of 20 is equal to 65 over here. See? 20, 65. And f of 30 is equal to 80. So what are we doing? Are we going to do 80 minus 65 equals 30 minus 20. Order doesn't matter here as long as you keep them straight top to bottom, okay? So that's going to be 15 over 10, right? Which is what? 1.5. And guess what that velocity is right there? It's equal to 1.5. So this one is according to the MVT. This is the mean value theorem, right? So according to the mean value theorem, when c is between 20 and 30, h prime of c equals 1.5. Here's our next example. Skater Sally's riding a skateboard back and forth on, oh, let me go back to this one, what I didn't talk about. This has got to be differentiable, okay? So differentiable, differentiable. And again, we know that that's true because it says twice differentiable there, okay? That's got to be true for this MVT to be working, okay? So this next problem says the same thing. Skater Sally's riding a skateboard back and forth on a street that rides north-south. The twice differentiable function s model Sally's position on the street by how many meters north-south. Okay, it says, again, for the interval 0 to 20, there must be a time t when Sally's 2 meters south. Okay, so this is going to be a -2. That's the trick to this question, of her starting point and explain. So again, this is going to be IVT, intermediate value theorem, okay, because we're trying to find out if there's a point when between 0 and 20, the S of t is going to be -2. So again, we're looking between 0 and 20 right here, right? So when the time is between 0 and 20, notice here, what are our y values? Between what? So our S of t is going to be between 0 and -5, right? Okay. So obviously -2 is between 0 and -5, right? So the answer to this is going to be yes. And according to IVT, that's why. Okay. So the next one we're going to use MVT, right? And again, this is true because it's continuous, and it's continuous because it's twice differentiable. Wow, my pen is not working. Okay, this is differentiable because it's twice differentiable. Okay, and those are the conditions, okay, for us to be able to do this. So now this one, again, what are we looking for? We're looking for slope, okay? So this time we got between 30 and 60. So if we do S of t, so if we do S of 30 and S of 60, so S of 30 is 7, right? And S of 60 is 40, okay? So it says, must there be a time when Sally's velocity is 1.1? So here again, we're going to take our y values, 7 minus 40. Remember, I said order doesn't matter. We just got to keep it straight top to bottom. And this is 30 minus 60. So that's going to be minus 30. What is that? 3 over minus 30, right? So that, put that in your lovely little calculator. And when you do, you're going to get... Where's this problem? I lost it. Oh, it's on the next page. That's why. I got 1.1. So because they're equal, right? 1.1 is equal to 1.1, and that was the value velocity they asked us up here, right? Then we know that the answer is, wow, what happened? Okay, because they're equal, then yes. Again, according to MVT, this is true because between the range when t is between 30 and 60, S of t is equal to 1.1. All right, let's see if you guys can do the U-try. Come back to me when you're done. So here again, what are we doing? We're going to, oh, where did my table go? My table disappeared, so I'm going to build it right here real quick. I don't know where it went. So this is t and it's seconds, and this is S of t and it's centimeters, okay? So this was 3 and 10 and 20 and 25. And this is 5 and -2 and -10 and 8, okay? So again, from 20 to 25, again, we're going to look at the intermediate value theorem. So between 20 and 25, so in this range over here, 20 and 25, is there a time when the particle's at the origin, which would be 0, right? So when t is between 20 and 25, S of t is between what? Isn't it between -10 and 8? So obviously -10 and 8, yes, there's going to be a value of 0 there, yeah? Between 3 and 10, remember we're going to do s of 3 and s of 10. Oh, and by the way, again, remember, because that's twice differentiable, we are going to, says the particle is moving along the x-axis. The twice differential function s models the particle distance from the origin measured centimeters in time t, measured in seconds, okay? So what does this mean again? So this has got to be continuous, and it is continuous again. Why? Because it's twice differentiable. This is differentiable because it says it's twice differentiable. Okay? All right, so we're going to go ahead and find these values. S of 3 is 5, and S of 10 was -2. So once we're going to go delta y over delta x. So we're going to do our 5 plus 2, because it's minus a minus 2, and 3 minus 10, so that's going to be 7 over -7. And so I got -1, and is -1, here's our question. That's what it's asking us about, right? Must there be a time t when the particle's velocity is -1 per second? Yes. So the answer here is a yes again. Why? Because according to MVPT, between 3 and 10, there is this value right here, and they are equal.